I'm going to talk about some work I'm doing right now, which is practical stuff of running AIs in virtual worlds such as Second Life. And I'm also going to talk more broadly about what I see as a long-term future of AI in virtual worlds and why I think AI is important in terms of helping virtual worlds get where they need to go, why I think virtual worlds are important in terms of helping AI overcome some of the obstacles that it's faced. And I'm going to try to go through the presentation in maybe 20-25 minutes, and then we can have a discussion about various possibilities afterwards. Whether that happens or not, we'll see. It probably depends on how many conversational interruptions there are while I go through the thing. So I'm going to talk about, in general, why I think AI and virtual worlds are a good partnership. Then I'll talk about the specific application we're making now, which is virtual animals in Second Life, which some of you just shot a little video of. I'll go over that machinima in more detail and explain what's going on. Then I'll talk a bit about natural language processing and reasoning in AI, and what we can do with it now without virtual worlds and embodiment, why I think virtual worlds and embodiment can help us overcome some of the issues that arise there. So for those of you who've seen me give talks on this recently, for example at the Singularity Summit, the virtual dog hadn't yet been unveiled at the Singularity Summit. We showed that off at the Virtual Worlds Conference a couple weeks ago. But the new content here is more some things about language processing and reasoning and how they tie in. So as this slide says, we're starting off our exploration of AI in virtual worlds with virtual animals that learn, but that's just the beginning. You can think of a whole bunch of other interesting things to do, from virtual talking birds, virtual shopkeepers, bartenders, job recruiters, a digital twin that stays online all the time and does whatever you'd like to do when you have to be in your first life and can't be in Second Life. Ultimately, what I'm really aiming at is virtual scientists. I know for those of you who saw Melanie Swan's talk yesterday, she was showing some nanotech stuff that's going on in Second Life right now. What if you had a real research lab in Second Life with real virtual scientists analyzing data, showing it to people, and making scientific progress faster than human scientists can do? So there's a heck of a lot of possibilities, and it's something that we can make real right now. I mean, AI software is real, virtual worlds are real. It's not something where we need to make roadmaps and action plans and theorize. We can actually get out there and build the technology and put it out for people to interact with. One of the interesting things you can do with it is overcome many of the bottlenecks that exist in terms of having computers interact with people using natural language. A brief bit on terminology before we get into more interesting things. I'd like to talk about artificial general intelligence as distinct from what I call narrow AI. What I mean by AGI is AI systems that really have some sense of autonomy of their own selves, their relationship to the world, that are able to conceive of a problem and figure out how to solve that problem, even if the problem was not known to the programmers who created the program, which is a different thing than the narrow AI program, which may be very smart at solving some particular problems. Google is great at translating keywords into lists of URLs, and the programs that the various researchers are playing around with in the context of the DARPA Grand Challenge, these programs are increasingly good at driving cars, which is a good thing. As I always say, I'd like to see every other driver replaced by a computer. Chess playing programs can beat the hell out of me at chess. We haven't solved Go yet, but I'm confident that it'll be solvable. But each of these programs does one thing. What you really want is a program that is generic, not just by being a grab bag where you put 50 different specialized programs in one container, but something that can generalize and abstract beyond many different individual problem domains so as to be able to confront new problem domains that were never even dreamed of when it was first written. And one of the most surprising and frustrating lessons in the history of AI is that success at narrow AI, at solving particular problems, is not all that much use if your goal is to solve general AI. And that was a shock. In the 60s, people thought it would be. They thought, well, if we can solve chess and algebra, of course we can solve, like, walking down the street and playing fetch and, playing 20 questions, recognizing a face, going to kindergarten. But to our surprise, it was easier to make computers that could play chess and take integrals and derivatives than that could pass kindergarten, right? So, I mean, that's a non-trivial lesson, I think, as to how difficult these things we take for granted are. The reason they seem easy to us is because we've got so much awesome genetic programming to help us handle them, but it doesn't mean they're fundamentally easy. And I've been putting in some effort in the last couple of years trying to catalyze the AI research community toward addressing these questions of general intelligence rather than just focusing on solving particular problems. So we have a conference that Bruce Klein, who's my collaborator on Novamente, our AI company, that Bruce and I are organizing. It's a conference in Memphis in March 1st to 3rd, 2008, which is the first serious research conference focused only on artificial general intelligence. So we've got a whole bunch of around 50 academic and university and industry researchers coming in from around the world to discuss their research pertaining to building general intelligences. And I think this is important. When the AI field was started, way back before I was born, the focus was on building thinking machines. For sort of practical reasons, the field has drifted more toward narrow problem solving, but a number of us involved in the field are trying to direct it back. So let's say you buy that that's the right thing to do. Instead of focusing on narrow problem solving, we should focus on general intelligence. Make a thinking machine. The smartest people are ultimately smarter. Well, what's the right way to do it? Of course, there's no common agreement on that. There's some people at Google saying Google is an AI company. They'll make smarter and smarter search engines until eventually it'll be able to understand natural language like a human. So that's one avenue. Another avenue is physical robotics. Some thinkers, such as Rodney Brooks, will tell you that's the only real path. Only by engaging with the physical world, with all its sensory and motoric richness, like we humans do, can you get an AI system with a general intelligence similar to humans. So my own view is somewhere in between those two things. I don't think a body is necessary for AGI. I think a body is very useful for AGI, especially if you want to make your AGI be anything like human beings, since we're rather tied to our bodies. I see no reason you couldn't make a massively superhuman AGI that did nothing but prove math theorems and whose whole input and output was mathematics. However, it'd be hard to figure out how to create that thing. It'd be hard to debug it. It would be hard to relate to it. It would have a hard time relating to us. So there are many practical advantages for embodiment. It's an overstatement to say it's necessary. The next question is, what kind of body do you need? Do you really need a physical robot? Is a robot good enough? Do you need something which really has like skin and all the richness that a human body has and kinesthesia and so forth? Or on the other hand, is a virtual body good enough? Something like this little girl here we have in Second Life. Obviously that doesn't have the same richness of experience as a real little girl. On the other hand, maybe it provides what's needed for an AI. And maybe if it doesn't this year, it will next year or the year after that, because the rate of improvement of online virtual worlds is extremely fast, much more so than the rate of improvement of physical robots. So my inclination is to believe that virtual world embodiment is rich enough as an embodiment vehicle for AIs to confirm most of the advantages you'd get from physical embodiment, and it's just a heck of a lot easier to work with. So I started fiddling around with embodying our AI system, the Novamente Cognition engine, in 2005. The basic AI system I'm working on, the Novamente engine, we started development of that in 2001, and have been doing it sort of for a while as a background R&D project while we focused in the foreground on various AI consulting projects. Recently the AI engine itself has moved into the foreground of our efforts. But our first experiments with embodying the AI engine were just in a simple game engine. We used the open source game engine Crystal Space, built a little world on top of it. The AI controlled the little guy you see there, and the big guy is controlled by a human. This was actually a screenshot of an experiment which we did to try to teach the AI something that psychologists call object permanence. To put simply, you want to teach it that when it's not looking at something, the thing still exists, which is hopefully obvious to everyone right here. It's not obvious to a 5 or 6 month old baby. Human babies learn that somewhere between 6 and 9 months, generally speaking. Our AI had to learn that too. It didn't know that. It just learned it through experience. When something's hidden and it looks in the same place again, more often than not, the thing is still there. If not, it may be somewhere else around. And of course, not all virtual worlds would have that property. You could build a virtual world without object permanence, but we chose not to because we wanted to teach it that. But one thing you notice about a virtual world like this single room we built is it's kind of empty. There's even less going on there than in Second Life. And it seems clear that public virtual worlds provide a lot more avenues for teaching AI's interesting stuff. There's people building stuff there all the time. There's people and other agents walking around doing things. It's not as rich as the real world yet. Ultimately, it may be richer than the real world, but it's certainly much richer than a single room you could build as a kind of toy domain. And one of the most interesting things there is the potential to have tens of thousands, hundreds of thousands, millions of people teaching your AIs, interacting with them, teaching them both explicitly by correcting when they do something idiotic, or just implicitly by giving them examples to watch and interacting with them. And this can be something very, very powerful. I mean, if you think about it broadly, Google has much of its strength from what people put into it. We build links on web pages. We upload text through Gmail. We click on ads. That information from human activity is what makes Google powerful. And Wikipedia, of course, is the same way. People are putting that information in there. The computer tools are serving as a medium to let human intelligence be properly organized so as to help enhance other humans' intelligence. If you have human beings teaching AIs in virtual worlds, in a similar way, you have many human beings all collaborating to make these AIs smarter and smarter. And since the AIs all can be connected on the back end, what you teach one AI can ultimately benefit other AIs, and the community of virtually embodied AIs can get smarter and smarter based on the collective teaching of all the people online. And this is a very powerful dynamic. It could be achieved with physical robots, but it's just more expensive. You got to create a bunch of physical robots and distribute them all over and get people to use them in their everyday lives. Whereas online, once you've created one, replicating it is significantly less expensive, although there is computer hardware cost, of course. So we're starting out with virtual animals, which are letting us deal with the integration of perception, cognition, emotion, personality, social interaction. Very simple language in terms of accepting commands. What I'm looking at is step 2 of this, which with luck we would roll out maybe a year from now, would be virtual talking animals. The vision I have in my mind is a virtual talking parrot, because I figure if its language facility is kind of idiotic at first, the end user will be forgiving since it's just a bird, right? The fact that they can talk at all is sort of impressive. And the potential of these birds for language learning can be pretty awesome, I think, because if you have, let's say there's 50,000 people in Second Life now. Of course, Second Life is just one virtual world, but just to take that as an example, let's say 20,000 of them had virtual birds, which, depending on the business model, is not at all infeasible. Things can be adopted very rapidly in the world. You got 20,000 people online at any given time, and the virtual bird is listening to them and maybe giving them information about what's going on somewhere else, what their friends are doing. That's an awful lot of teachers. That's a lot more than any human baby has.
Sorry, to make them learn faster, could you do 20,000 instantiations of the same AI?
What we're going to do is something in between that and having them all be individual. I mean, on the back end, they essentially are 20,000 instantiations of the same AI. It's all one server farm. On the other hand, from an end user point of view, we believe people will like having animals have some individual personality. So the software object encapsulating an individual animal has something called a personality filter attached to it, which controls how much of the collective animal unconscious gets to filter into that individual animal.
That's great.
Some people think the human brain works that way too, although I don't subscribe to it. Yeah. Another product that is a little further down the road that we're very excited about is virtual babies. And this was actually the most tame virtual baby I could find in Second Life, given the nature of Second Life culture. But I think that has a lot of opportunity as well. Give people a virtual baby. Say, well, it's not that smart at first. Have it for a few years. It'll improve. It'll get more and more intelligent as you teach it. And if you don't like it, you can just throw it out and get a new one, which doesn't work with real babies, at least in this country. Right? So mostly I'm going to talk from an AI point of view. From a virtual world's point of view, I think AI makes a lot of sense too. So I'll spend about a minute on that. I mean, if you go in Second Life right now, it's a great thing. I do believe it's the Second Life, MetaPlace, other tools like that are the beginning of the metaverse, which is going to have a huge impact on the evolution of intelligence on Earth. There's a lot of problems with it right now. I mean, some of them are just software problems. The server's not as scalable as it could be. The learning curve is measured in weeks rather than minutes. Another issue is just that the virtual worlds are kind of empty. I mean, if you know where to go, you can find interesting stuff going on, but they're not exactly teeming with life like the rainforest and so forth. And I think adding AIs can make virtual worlds a lot less empty. Ambient wildlife, opponents for in-world games, companions to show you around, virtual shopkeepers and so forth. So AI has a huge potential to increase the usefulness of virtual spaces out there. Many of the virtual spaces are empty because whoever built them didn't want to pay someone to staff them. Of course, what you want is for communities to spontaneously evolve, but just as with any other kind of organization, having a seed to help catalyze the organization of a community can be important. If an AI is sufficiently non-idiotic, it may be able to serve that role. So there's a whole bunch of possibilities here. I mean, if we sat here for an hour, we could dream up 1,000 possibilities for AIs in virtual worlds. That's not really the hard part, but some of them are obvious ones. Are salespeople, customer service representatives help you walk through the problem with your computer by looking at a virtual computer in Second Life. Or, here's the power cable. Your computer has one of those, right? Is it plugged in? Tour guides to replace search in Second Life. Someone to go shopping for you. Matchmakers, they can go hit on chicks for you, and they can absorb the pain of rejection. My favorite idea is the virtual Amway salesman. Have an AI salesman whose goal is to sell other salesmen, whose goal is to sell other salesmen. And ultimately, when you go all the way down the hierarchy, what the final salesmen are selling is repellent spray to kill Amway salesmen. You know? It's my ideal plan for crashing Linden Labs' Second Life servers. Right? So my company, Novamente LLC, is working with Electric Sheep Company. And we have a partnership aimed at rolling out a series of more and more intelligent agents in not just Second Life, but other virtual worlds over the next few years. So the first thing we're doing is virtual animals, and we haven't quite decided on the business aspect of exactly how they will be introduced to consumers and what the business model will be. We're discussing a bunch of possibilities, and we plan to launch this. We don't have a launch date, likely the second quarter of 2008. The virtual animals that we're playing with now are dogs, although the AI is pretty much generic. We could apply the same AI to any animal that operate on the ground. Anyhow, we haven't done a lot of 3D stuff in terms of birds flying around yet. That has spontaneous behaviors. Each animal has its own goals, and it tries to learn plans to fulfill its goals. Their inbuilt goals are things like, I want food, I want water, I'm bored, I want novelty, I like social interaction. We don't actually have reproduction in there yet. It's not decided. That's going to be in the first version. Yeah, we're worried about what the Second Life human population might do with it. But, and in addition to spontaneous goals, a key feature is the ability to learn new behaviors from human teachers. And there's three aspects to that. One is copying what people do, what I call imitative learning. The other is reinforcement learning. It tries to do something you told it. No, bad dog, you stood up when you're supposed to sit. You correct it. The other is like physically corrective learning. If the dog's supposed to sit and it gets up, you push it back down. So through these three kinds of interaction, you can teach the virtual animals to do different things. And that brings us to the little machinima that I showed. Now this machinima was made by a combination of AI and cheating. Because the state of our project right now is we have the AI learning engine working on the back end, and Electric Sheep is still working on the proxy code that connects Second Life to our AI code. It works, but still has bugs. So the limitations were patched over here with some just direct LSL scripting. So this is part AI and part smoke and mirrors, but it's illustrative of what a small subset of what the product is intended to do. So now he's trying to teach the dog to sit, and if you go back a little bit, he somewhere gave it a command that said, "Hey, pay attention to me." So he says, "I'm sitting." Now the dog understands very limited subset of English, but it understands that means, I'm giving you an example of some behavior. Pay attention, record what you're seeing, because I may ask you to try that again later on. Oops, that's too fast. No, not at all. That doesn't have to have anything built into it. Watch, because it watches you do it. Then you say, try sitting, and it tries it.
I think he's asking about the physics model of the dog.
Oh, what it has... Correct. Okay, so it doesn't have sitting built into it, but what it does have built into it, which is kind of cheating, is a mapping between some animations that a human avatar can do and some animations that... But it's at the level of, like, limb movements. It's not at the level of sitting equals sitting. It's at the level of, that's his leg, that's my leg. He moves his leg, he contracts his leg, that's equivalent to me contracting my leg. He turns his head, that's equivalent to me turning my head. So it's yeah, it maps an animation, and an animation corresponds to a kind of individual motor action.
That's not that far from imitative learning in first life.
No, but I mean a dog has to understand that its leg is analogous to your leg, and we're giving that to this guy just because there's basically no other way to do it in Second Life, because animations are done by running animation scripts rather than using bones-based animation. So then when he says try sitting, it knows it's supposed to try it. Then he gives it a reinforcement signal, good or bad. Now, one of the easier ways to teach the dogs is to recruit an accomplice, where the accomplice will act something out. Then it's supposed to just copy the accomplice. And what that does, it means the dog doesn't have to work to disambiguate kind of what you're doing that it should copy from what you're doing that is your behavior. Like if you're playing fetch, you don't want the dog to imitate throwing the stick. You want to imitate getting the stick. Now, the AI can disambiguate those things automatically. In a case like fetch, it's actually easy for the AI, but in general, it's simpler if the teaching function and the exemplar for imitation function are separated. There's a whole bunch of parameters that govern a dog's personality. Actually, there's a couple dozen of them. So I went through a whole model of human personality, then the models from psychology of human emotions. And I was amused to find that pretty much every human personality trait and every human emotion is found in dogs. So, I mean, dogs can be jealous, they can be resentful, spiteful, as well as just happy or sad. And I think, so one of the things that we've done initially is just to hard code various emotional reactions to situations. But they're coded inside our AI's knowledge representation so that they can be adapted and modified based on the dog's experience. So even if the dog is initially wired to be jealous about certain things, it could learn not to if its experience guides it. So one thing I'm not going to have time to talk about in the next 5 minutes or so of the presentation is the actual AI learning engine underlying this, which is something I've talked about in previous conferences, which is a big topic unto itself. I mean, we have our own whole integrative AI approach, which we're intending as an architecture for a true thinking machine. And there's many years of research and thinking gone into that. But just to give a extremely high-level overview that will mean a little bit to people who already know something about AI. I mean, the knowledge representation is a weighted labeled hypergraph. It's nodes and links. You could view it as a kind of midway point between an attractor neural net and a semantic net. And the nodes and links have probabilistic truth values attached to them. They also have what we call attention values, which indicate the short and long-term importance of a node or link to the system. And there's a certain nonlinear dynamic that updates the long and short-term importance values based on the system's activities to decide what the system should pay attention to, what it should keep in memory, there's a probabilistic logic engine that updates the probabilistic truth values of nodes and links. And then there's an evolutionary learning system which uses a kind of combination of probability theory with genetic programming. That's something called MOSES, which is described at metacog.org in the PhD thesis of one of our former staff. And that system kind of learns new procedures for carrying out tasks, but then can represent the procedures as probabilistic knowledge to be reasoned on and stored in the node and link knowledge base. So it's a kind of complex integrative architecture using probability theory as a common language to mediate between logical reasoning, evolutionary learning, and a few other simpler things, and a big hypergraph knowledge base. We have the belief that this AI architecture is going to be adequate to actually make a human-level thinking machine. I'm not going to try to defend that in the next 37 seconds, but you can look at Novamente.net, which is a website of our company, and there's a number of conference white papers, like 6 or 8 pages from various AI conferences, which will not satisfy you thoroughly either. Of course, it's a big thing, but if you look at that stuff and are intrigued, you can email me and I can give you access to some proprietary material on it. I mean, we haven't published too much on it, but we're not all that secretive either if people are curious. We have a book on that coming out next year from Springer Verlag, just on probabilistic logic networks. So that's like a whole domain unto itself. So getting back to the pets, although I would rather talk about the AI system, that's a longer and deeper topic. The software architecture that we're using here looks like this. So the virtual world is at that end. There's the proxy, which is the main part that's not finished yet, which goes back and forth between Second Life and the pets. We have a server pool that actually controls the pets. That has an object for each pet, and it schedules between them. That contains basically the short-term memory of the pets, the procedures that the pets already know how to do, which are then triggered by various situations that the pets find themselves in. Collective experience server over to the right is kind of the collective unconscious and long-term memory of the animals. And then for learning, we use 2 things. We use hill climbing, which is a simple, fast heuristic for searching through the space of possible procedures to control actions to achieve goals. And then something we call MOSES, which is a probabilistic evolutionary learning algorithm, which is slower to run but can solve harder problems. And the first release is going to have all those. The things that are in red are stuff that exists but is more prototypey, and we'll make it into the second release. PLN inference, probabilistic logic network inference. So the first version of our virtual dogs won't actually have a logical reasoning engine, and it'll just be evolutionary learning to learn procedures to achieve goals and to do tricks that was taught to it. Then in the second version, we'll integrate the logic engine that we built for other applications in there. Object recognition is something else we haven't built yet, but need to. I mean, some objects in Second Life are labeled with metadata, but ultimately you want to look at a glockenspiel and figure out it's a glockenspiel. Or look at a chair and figure out it's a chair. I mean, that's a whole subset of AI in itself, but it's easier in Second Life than with real image data, obviously, because you're dealing with polygonal meshes. This is just a little picture of what a little scene in Second Life looks like to the dog, which isn't as pretty as Second Life, but just a little two-dimensional map, sort of like the back of the dog's retina, you could think of it as. So, in terms of developmental psychology, if you look at Piaget's stages, for the dogs, we're kind of between the infantile stage and what Piaget called the concrete operational stage. And the real trick is to get to what he called the formal stage, where you have things that can reason and hypothesize. And we're not going to get there with dogs. That's what we're hoping to do with talking parrots. So, just a couple more minutes. I want to give something new for those who have seen this spiel before. Why do I think virtual worlds are important for AI? Part of it is that you can get a lot of people to interact with your AIs. Part of it is that you can hopefully get people to pay for various things associated with AIs, new behaviors for them, new tricks, and so forth. Part of it, though, is I think AI can get past its bottleneck of human language understanding and human common sense understanding through embodiment in virtual worlds. So I spent a lot of work doing natural language processing for corporate customers because Novamente needs to make money as well as trying to build a superhuman thinking machine. And what we find is, we can do a lot of cool stuff with natural language processing, but you get stuck on some problems. And here's some of them. I mean, our system, our natural language processing system, it can parse a sentence correctly almost every time. The problem is it also parses it incorrectly almost every time. And selecting the right parse out of the list of 50 parses of a sentence out of Proust or something can be difficult. Disambiguating word meanings can be hard, especially for adverbs, adjectives. Disambiguating prepositions is like uncharted territory. There's almost no research papers on it. It's only like, I ate lunch with a fork. I ate lunch with my friend. I ate lunch with salad. I ate lunch with great enthusiasm. All those meanings of with. There's no computational linguistic systems that deal with that. Reference resolution, another thing. Like, the terrorists blew up with my house. Then the bastards clobbered my dog. The bastards refers to terrorists. So that's nominal reference resolution. We're pretty good at that, but AIs aren't good at that. There's a whole bunch of language phenomena. Comparatives are another thing. I eat more than you. Does that mean I eat more food than you eat, or I eat more than 70 kilograms, or whatever you are? This is obvious to a human, maybe not to a cannibal, right? But it's obvious to humans in our culture. So Google is a great system, but it hasn't solved this problem. I like to play around with using Google as a question answering system. Ask Google, like, how many years does a pig live? Well, it's not too bad. Some pigs live 15 years, guinea pigs 1.5 years. I ask it, that's hard to read here, how many years does a dead pig live? And it doesn't get it, right? It gives all kinds of weird stuff. How many years does a pig live in captivity? That's simpler, but it still doesn't get that, actually. It gives you stuff about alligators and other animals. So even if you're not asking a trick question, it doesn't understand modifiers. It doesn't understand context. And some people are trying to overcome this problem. Barney Pell and his colleagues at PowerSet are working on that, and you can ask it questions like, who mocked Blair? And since Tony Blair from Britain is the best-known Blair, it finds examples of people saying they made fun of Blair in different languages, in different metaphors, and that's reasonable. It's a step beyond Google, but it still doesn't handle most of the problems that I cited on the previous page. And just to go over this in slightly more detail, if you feed a sentence like, guard my treasure with your life, into our language parser, this is the kind of thing we've been working on in terms of the virtual dogs, actually. Version 1 isn't going to use this language engine, but we'd like to do that. Our language parser, it knows your and life as a possessive, treasure is the object of guard, with binds guard to life, and so forth. So the language parser can do that. We have some semantic mapping rules that try to figure out what it means. So it maps that out, like the protection is you, the asset being guarded is the treasure, blah blah blah. So it can actually map out a lot of the semantics of the sentence into relationships, which is nice. I mean, we've used this stuff to build various products, but think about the difference between guard my treasure with your life and guard my treasure with your sword. They're not exactly the same, I mean, but they're mapped the same by our NLP system right now, based on pretty much cutting edge or beyond cutting edge NLP technology. How about guard my treasure with your uncle? No? I mean, you could be kind of picking up the uncle and clobbering the thief with it, or on the other hand, it could mean you and the uncle together are doing it. That would be mapped differently. You want to get to, as you see at the top, you are the protection and the uncle is the protection, right? But that requires disambiguating with, based on common sense, that the uncle is more often the agent of guarding than the tool. And we can actually handle this example, but it's a simple example. The problem is analogous phenomena occur with much more complex things.
Or I might have half a dozen treasures, one of which is with your uncle, and that's the one I want you to guard.
Yeah, the treasure could be in the uncle's pocket, right? And that's hard. So, I mean, if you just, I made up a little paragraph here just an hour ago, just to show the combination of phenomena. This is not that hard a paragraph. I have a magical broadsword in my closet. It's stronger than you think. Well, right there's a problem, right? Is it strong? It's stronger than you think it is, right? It's not stronger than your power of thought. Protect my treasure with it. Now that means you know what sense of with is intended. It also assumes you can bind it back to broadsword rather than closet, for example. After you get rid of them, lie down with it. Go to sleep. Well, that's go to sleep is an idiom. You can assume the system knows that. Don't let go of it. It has to know what it is, not the rock that you're sleeping on, but the sword. After you sleep, if you're too weak to lift yourself up, the gravity field varies here. Now, is that on the rock or on the planet you're on, in whatever context this is? That's kind of context-dependent assignment of an antecedent. Stick the thing in the ground and get up with it. The thing has got to be the sword, right? And we know that, but that's because we have a kind of picture in our mind and knowledge of what's happening. So a simple paragraph like this, an intelligent 5-year-old kid would just get it, right? And, I mean, the most sophisticated AIs right now don't get it because language is full of all these referential phenomena that assume context and common sense. And my belief is that the way to get an AI to understand this kind of language is to create an AI that can experience these kinds of events. And I think a virtual world is good enough to let an AI experience those kinds of events, which is why I think virtual worlds are good enough to get you to general intelligence. Because if you can have the system experience enough things to understand language at the level of a young child, then the system will be able to understand language at the level of a young child. Then you can talk to it. Then you can teach it all the things you want. And so I think the obstacle we need to overcome is not passing the Turing test. It's being able to talk to it like you can to a 5-year-old kid so that you can teach it more and more. How do you overcome that obstacle? The problem is overcoming all these funny phenomena of reference, disambiguation, and so forth, which are needed in order for us to be able to communicate compactly, sensibly, and intuitively with another being. What I'm looking at here, the kind of reasoning we can do now if we kind of cheat a little bit and tune everything right. We look at simple English Wikipedia, which is a version of Wikipedia with very simplified language. We want it to learn that eating chocolate makes you feel more awake. We want it to learn that because it knows caffeine makes you feel more awake, and caffeine and theobromine, which is in chocolate, are related. And you can do that if you use simple English Wikipedia, where you have simple sentences like caffeine is a stimulant drug. You can get the nodes and links inside the system. Chocolate contains theobromine. Caffeine is closely related to theobromine because this sentence says so. Caffeine is a stimulant. The node, you can put all that stuff together inside the system's reasoning engine, and it can figure it out. And that's fine. But if you look at the real Wikipedia rather than simple English Wikipedia, then you're back to sentences that are more difficult. And the idea that you could get that through a sufficiently large corpus is obviously true, just as the idea that sight could work from a sufficiently large database of predicate logic relationships is obviously true. How large is the corpus that Google would need? Is it 10 quintillion or 10 nonillion documents? I mean, I think the fact that it can't even answer how long will a pig live in captivity now tells you something. It's because there's not enough sentences that are directly of the form, a pig in captivity lives up to this many years, right? That information is implicit among a lot of sentences, and to get out that implicit knowledge requires you to be able to solve all these problems, right? So I guess I agree those things could work in principle. It comes down to an estimate of how big does the corpus have to be. My guess is that as long as texts are produced by human beings, we're not going to produce enough because we only reproduce at a certain rate. You know? Well, we're out of time and I'm out of presentation, but if you have more questions, I'm happy to answer them.